Hi, my name is Raj Siman Ravichandran, and my partner's name is Christina Chapareska. Our project is VM user behavior analysis using OSSEC on Savvy Testbed. A little bit of background regarding OSSEC. It is a host-based intrusion detection system uh, where it can be thought of as an anti-malware or antivirus systems for Linux machines. It is an open source tool, and we try to incorporate that into the Savvy testbed. And our project's main contribution was to incorporate user behavior analysis for OSX abilities. Here we tend to use um, a machine learning model to uh, profile user behaviors using uh, input shell commands and try to profile the users and detect any intruders in the system. Um, so I would like to show a little bit of background of the OSSEC components. There are two main components and two subcomponents to the OSSEC. Um, First one is the OSSEC server, which contains all the detection engines, rootkit scanning, all sorts of and virus signatures to do the detection, and an agent where it resides in each VM, and its main purpose is to provide logs or information such as system call distribution and memory usage for the OSSEC server to perform scanning. The other two components are basic user interfaces to visualize the alerts or logs detected on the agents. And here we show the platform architecture that we incorporated for our project. There are three extra components that we developed, one being the trap component, the intruder response script, and the intruder detection engine. The trap command basically logs each command um, entered on the residing host and sends those log files to this OSSEC server. When a sudo command or a root privilege command is entered, an alert is being triggered on the OSSEC server, and it executes an intruder response script. The active response script will feed the information to the intruder detection engine, and based on the response of the engine, it would notify the user or the system admin of the infrastructure. Uh, so a little bit in detail information about the intruder detection engine itself. Here we incorporate or implement a naive Bayes machine learning model, supervised model, and we use a public test set of Unix commands um, provided by Purdue University, where we can train the intruder detection engine to classify users. And based on our experimentation, we figured that the accuracy is 69%, which shows that it is better than weak classifiers, but this can be definitely improved by either using complex models such as neural networks or ensemble methods, or we can increase the accuracy by using larger data sets. And in the demo workflow, we try to execute a command in a monitored VM, and the alert is triggered when a sudo command is entered, and the intruder response script will send it to the intrusion detection engine. And if it's an intruder entering the command, then an email will be sent to the system admin. Now I'm going to perform the demo. In this terminal, I am inside a VM. And then the right hand side terminal here, I'm on the OSSEC server VM, listening on the one of the log files to see whether an alert is triggered or not. So here I enter a command as an owner, or something classified as an owner, to show that that an alert is being triggered when a sudo command is entered, and the intruder detection engine provides the response as the owner, which means it's not an intruder, and an email will not be sent. Now, if an intruder enters the system and enters the command looking for a private file, and if that does not profile the owner of the system, then the detection engine will profile it as an intruder, and an email will be sent. Here in our intruder alert, so we notify the system admin that in this exact VM IP address, and also what the command has actually been entered, so that the admin can start the investigation and start notifying the owner of the system. Based on our experience in this project, we felt the need of doing a couple of future developments. One of them being, of course, improving our accuracy by using complex models. We also propose maybe using larger data sets. Another proposal that we want to use is, without using larger data sets, we can use unsupervised learning methods, such that it doesn't depend on complete historical data sets. And also we would propose a couple of other things. Here we try to even notify the system admins. We can also improve that response to block the malicious intruder, or the execution of that malicious command. That could be one of the improvements for the future development. And some of the flaws we found for the host-based intrusion detection systems is that an agent should be installed in each of the residing monitored hosts, which may not be ideal for many real deployment. That's why a prominent or future development would be to look into VM introspection methods, where the antivirus or the tool does not depend on agents, but just resides on the hypervisor and monitors the physical memory or any resources usage, and tries to build a higher level semantics to detect any malicious code execution. This concludes our demo presentation, and thank you for your time.